Hello dear students, let us solve a problem on electrostatics based on Gauss law. So the problem statement is a solid sphere of radius r carries a non-uniform charge density given by the expression rho of r is equal to rho naught into 1 minus small r by capital R. So we need to find electric field inside the sphere and outside the sphere. So that is our aim. So let us understand the problem. So here the charge density is not at all constant. At the center its value is rho naught, and whereas at the surface it becomes 0. So it gradually decreases and becomes 0. So we cannot directly apply the rules of a uniformly charged sphere. Now we go for Gauss law because spherical symmetry is preserved here. So the charge density not only depends on r, not on the polar angle theta or azimuthal angle phi. Okay, so that's why we can go for Gauss law. So now let us recall Gauss law. So what states the electric flux coming out of a surface is equal to charge enclosed within the sphere divided by epsilon naught, that is permittivity of the free space. So in mathematical form we can write integral E dot dA is equal to Q enclosed by epsilon naught. Okay, so to solve a problem, we draw a closed surface around the point where you want to find the electric field. So which is called a Gaussian surface, just like shown in this figure. So this is the given sphere. Now if you want to find electric field at a distance r, so this is at a distance r. So we draw a imaginary surface. This is called Gaussian surface. Okay. So based on this, we will solve the equation. We will solve our problem. So first part is electric field inside the sphere. Electric field inside the sphere. So now we draw a Gaussian surface of radius small r. So this dotted line is Gaussian surface. Gaussian surface. Okay. To find the electric field via Gaussian surface, now we evaluate the each side of the Gauss law. So this is Gauss law. So now we will evaluate this integral separately and this part separately. Okay. Let's see. So if you observe the left side part, so let us draw a line. So here E dot dA. So here E and small volume element both are in same direction. Both are in same direction. Why? Because if we consider a small area here, so this is dA, so its direction will be like this, and electric field direction is also like this. So both are in same direction. So we can write E bar dot dA bar is equal to E into dA. We can exclude the dot. Okay, so now the integral becomes E dot dA is equal to, we can take it out, E outside of the integral, E dot dA. So it will nothing but E into A surface. So what is A surface? What is A surface? Surface area. Surface area of the Gaussian surface. Gaussian surface. So what is nothing but a sphere of radius small r. So what is the surface area of a sphere of radius r? So it will become a surface will become 4 pi r square. So the integral will become E dot dA finally will become E into 4 pi r square. Okay. So this is first part of the equation. Now we will solve other side. So that is this part. So here epsilon naught is a constant, it is permittivity. Now we have to find charge enclosed. What is that? Q enclosed. So that is nothing but charge enclosed in Gaussian surface. So this is very important. How to find charge enclosed charge? So Q enclosed can be find out using a equation integral, volume integral rho into d tau. So what is rho here? So this is given expression. So in the given problem, what is rho given as? Rho naught into 1 minus small r by capital R. And then what is d tau here? Volume element. Volume element of the sphere. Okay. So its value can be given as d tau can be given as r square dr sin theta d theta d phi. Okay, here r changes from 0 to r, small limits, and theta changes from 0 to pi, whereas phi changes from 0 to 2 pi. So now if we substitute these values to find charge enclosure charge, so enclosure charge will become 0 to small r rho naught into 1 minus small r by capital R. I am putting dash r dash square, okay, dr dash, and 0 to pi sin theta d theta, and 0 to 2 pi d phi. Okay, if we solve this integral will yield 2, and this will integral will yield 2 pi. Okay, so based on that above equation will become Q enclosed will become 0 to small r rho naught into 1 minus r dash by capital R dash square dr dash 2 into 2 pi 4 pi. So here rho naught is also constant. So we can take it all these things outside of the integral. So 4 pi rho naught integral 0 to small r 1 minus r dash by capital R into r dash square dr dash. So multiplying r dash into the inside. R dash square minus r dash cube by capital R into dr. So if we solve that, it will become 4 pi rho naught. So this is a simple integral, anyone can solve it. So r dash cube by 3 minus r dash power 4 by 4r, and the limits 0 to small r. Okay, so then the integral become rho naught into 4 pi into rho naught into r cube by 3 minus r power 4 by 4r. So this is the final expression for charge enclosed within the sphere. So now we plug this value charge enclosed charge in the given and the Gauss law equation. So what is that Gauss law equation? Integral E dot dA or is equal Q enclosed by epsilon naught. So we already found left hand side and right hand side equations. So its value become E into 4 pi r square is equal to 4 pi epsilon rho naught by epsilon naught into r cube by 3 minus r power 4 by 4r. So now we'll take to this value to the other side. So then E is equal to 4 pi rho naught by epsilon naught 4 pi small r square r cube by 3 small r power 4 by 4 into capital R. Okay, now we can cancel some items. For example, 4 pi get cancelled and r square cancel here and here. So finally we will be left with E is equal to rho naught by epsilon naught small r by 3 minus r square by 4 capital R. So this is the expression for electric field inside the sphere. So electric field inside means R is less than capital R. Okay, now we'll find electric field outside the sphere. So again we will draw a Gaussian surface at a distance small r from outside the given sphere. So this is this sphere is the given sphere, and the small charge dotted line is the Gaussian surface. Okay, again we will recall Gaussian equation E dot dA is equal to Q enclosed by epsilon naught. So actually we already seen that E dot dA will leave this particular integration will result E into 4 pi r square. There is no change in it. Now we will find charge enclosed. So here charge enclosure part will slightly changes. So enclosure charge will change here. Let us see. So here we will write line integral 0 to capital R rho naught into 1 minus small r by capital R. Okay, r dash square dr and 0 to pi sin theta d theta 0 to 2 pi d phi. Okay, as we have seen in the previous problem inside this sphere. So similarly here this value results 2 and this value results 2 pi. But if you observe here I'm writing the limits 0 to r. So that is crucial part here. That must be one should understand here. So why I am writing the limits, why I changed the limits 0 to r. So if you observe here, according to Gauss law, so we should consider enclosure charge within the sphere. How much charge enclosed within this given within this particular sphere? So this green part, this part is a given sphere and it is changed from 0 to capital R. Okay, and outside the sphere, this part is just empty space only. This total empty space only. So maximum charge is residing from 0 to capital R only. That's why we have taken that particular integrals limits. So if we simplify this, so 4 pi rho naught 0 to capital R 1 minus r dash by capital R dash square dr dash. So again we will solve this. So you already seen, so this is a simple integral 0 to r dash square minus r dash cube by small capital R into dr. If you finally solve this, you will get 4 pi rho naught into capital R cube by 3 minus capital R power 4 by 4R. Okay, if you simplify this, so you will left with 4 pi rho naught into R cube by 12. So which will yield pi into rho naught by 3 into R cube. So for Gauss law, we have solved this particular value and this particular value. Now we will plug both this value in Gauss law. So here we will get E into 4 pi small r square is equal to pi into rho naught by 3 into r cube. So here E will become outside alone 3 into 4 pi into epsilon naught small r square capital R cube. So if we simplify it and cancel some items, finally we will left with E is equal to rho naught into capital R cube by 12 into epsilon naught r square. So this is the final expression for electric field outside the sphere. So R greater than capital R. Outside the sphere, electric field outside the sphere. So this is how we will proceed. I think you understand it. Thank you.